This is a reassessment video for kinematics. The question says a suspension bridge is 60 meters above the level base of a gorge. A stone is dropped or thrown from the bridge. Ignore air resistance. And then at the location of the bridge, G has been measured to be 9.83 meters per second. If you find out if you drop the stone, how long does it take for it to fall to the base of the gorge? Part B, if you throw the stone straight down with a speed of 20 meters per second, how long before it hits the ground? And C, if you throw the stone with a velocity of 20 meters per second at 30 degrees above, at an angle of 30 degrees above the horizontal, how far from the point directly below the bridge will it hit the level ground? So first, I drew what's happening. This is my bridge. My gorge is 60 meters down below the bridge. G has been measured to be 9.83 meters per second. So we can go ahead and say that the acceleration in the y direction is a negative, because we're going down, negative 9.83 meters per second squared. We know that our y displacement, how much we moved down, was 60 meters. And we say negative 60 because we're moving downward in the y direction. Our initial velocity in the y direction is 0 because we're dropping the stone. And we're trying to find time. How long does it take? All right, so we're going to use this formula right here. It says y equals the initial velocity in the y direction times time plus 1/2 the acceleration in the y direction times time squared. So we're going to plug in our values. We know a negative 60 here. Our initial velocity in the y direction is 0, so that just goes away. Then we finish out the equation and we find out that t equals 3.5 seconds. So that's how long it takes. Part B, we can keep our picture right here so it helps us. B, now we're not dropping the stone, we're throwing it down. We're throwing it down with a speed of 20 meters per second, and it's going, like I said, down, so it's a negative 20 meters per second. Our y is still negative 60 meters. Our acceleration in the y direction is still negative 9.83 meters per second squared, and we're looking for the time it takes to throw the stone down to the bottom. We're going to use this equation again. Y equals the initial velocity in the y direction times time plus 1/2 the acceleration in the y direction times time squared. Now, even after plugging in all our values, we see that we have a t and a t squared. So we're going to have to use the quadratic formula. So here's our quadratic formula. Put it right there. We're just going to plug this up. I wrote here, this is our a, and we're going to set it equal to 0 to get it ready for the quadratic. And then I just moved everything on this side to get nice positive numbers. That's a, b, c. So after plugging it all in, quadratic formula, do some algebra, we get that the time equals 2.0 seconds. Part B, 2.0 seconds. Let me see that. All right, and then part C, we have a new picture that we had to draw because we're throwing the ball at an angle now. So here's our little man right here. That's my little man right there. The initial velocity is 20 meters per second squared. Meters per second. So then in the, we know we have an x component and a y component. So let's find the initial velocity in the x direction. It's going to be our initial velocity times cosine 30 degrees. We use cosine because now this is our right angle right here, and this is our x. So we're going to use hypotenuse over adjacent. Adjacent over hypotenuse, I'm sorry. So that's why we're going to use cosine when we're trying to find the initial velocity in the x direction. And we get 17.32 meters per second. Then the initial velocity in the y direction, it's going to be the initial velocity times sine of 30 degrees, and we get 10 meters per second. Now we're going to use this formula again. Y equals the initial velocity in the y direction times time plus 1/2 the acceleration in the y direction times time squared. We're going to plug in all our values, and we need to use the quadratic formula again. Set it equal to 0. Let's plug in our numbers, and we get that time equals 2.62 seconds. Now that we know the time, that's how long it takes for this to happen. But how far did it go? How far did it go? So in the horizontal or the x direction, we know that we know this velocity equals displacement over time. We know the velocity and we know the time. We're looking for displacement. So we're going to say 17.32 is our velocity. 17.32 equals x, our displacement, over 2.62 seconds. We solve and find out that it's 45.4 meters.